Hey everyone, my name is Eric Gonzalez. I'm a researcher at Google, and today I'm excited to be presenting our work, Augmented Object Intelligence with XR Objects, on behalf of my co-authors, Mustafa Doadoan, Karana Huja, Rufe Du, Andrea Colasso, Johnny Lee, Mark Gonzalez-Franco, and David Kim. So as we know, mixed reality has the power to enrich our lives by augmenting the world with useful digital information. Current solutions, though, are mostly focused on interacting with this digital content. Real-world objects, on the other hand, are often left out from a lot of these core XR experiences. Yet, as real-time AI systems continue to improve, our devices' abilities to understand the context around us is growing, as shown by this example of Google's Project Astra, where Gemini is integrated into a pair of AR glasses, enabling real-time question and answering with an agent. When we look at the AI interfaces that are currently available, though, we can see that while these models can often interpret the world pretty well, they're often limited in their ability to actually augment it. For example, here a user asks the system to mark which of these Japanese drinks contain lactose, which it fails to do even though it gives a valid text response. Back in the mixed reality space, you may have seen concept videos like this that show what world-anchored, object-centered interactions could look like in the future, like seeing relevant information overlaid on different products while shopping. But we're not quite there yet to fully realize this vision. There may be familiar interactions in existing digital spaces that can give us some inspiration. For example, on a desktop, every digital object has a context menu, which provides a set of actionable options that are relevant to each selected object. But again, in XR, these sort of object-centric menus are missing. Most of the menus are for launching apps or controlling the device, or generally not object-related. So to address this gap, we introduce XR objects. Using an interaction paradigm that we call Augmented Object Intelligence, or AOI, our goal is to make physical objects digitally interactive in XR. XR Objects is our open source prototype of this approach, which lets real-world objects serve as these portals to digital functionalities without requiring any pre-registration. This includes revealing summary information, asking object-specific questions, making comparisons, and anchoring spatial widgets. So using real-time segmentation and multimodal LLMs, AOI and XR objects can transform everyday objects into interactive tools when used in XR. For example, here a user uses XR objects to select a pack of pasta and directly ask its cooking time. They then can use that information to set a timer directly on the pot of boiling pasta, which remains spatially anchored to the pot as the user goes about the rest of their cooking. Here, analog objects are not only conveying useful information, but can trigger relevant digital actions. So how's our approach situated within existing work? Our method is object-centric, both in the content and anchoring perspective. So looking at the existing literature through this lens of these axes, we identified several relevant clusters. I won't go into too much detail here, but to make objects interactable in XR, previous work has looked at attaching both visible and infrared markers to objects, embedding electronics within them, repurposing them for input, or using them as haptic proxies, or mapping 2D apps to the object surfaces. In the end, we noticed that few works investigated how to automatically enable these object-centered interactions into everyday uninstrumented objects, which is what we call analog objects. And so we built our end-to-end pipeline to bridge this gap. So overall, our contributions here are a new interaction paradigm for blending real and virtual content, which we call Augmented Object Intelligence, our open source implementation of this example prototype, XR Objects, and an evaluation comparing XR objects against a standard AI chat interface. So our implementation consists of several components. First, we built this as a smartphone prototype, since camera access is currently limited on most HMDs. We'll refer to this again in future work, but as we'll see, this still provides us some useful signal as to the potential of AOI experiences. We perform object segmentation and classification on device via media pipe, 3D localization using SLAM and AR Core, and enable LLM interactions via Poly with additional search capabilities via Google Lens. So So our entire pipeline assembles all these various APIs and SDKs in Unity in the hopes of facilitating a rich interaction layer between users and the objects around them. So we identified 7 different actions a user could potentially take on objects, which we combine into the following 4 categories. Information, where users can get an overview or ask a question. Comparison, which is allowing users to compare multiple objects in their view. Share, which is sending an object to a contact or adding it to a shopping list. And anchor, which is spatially anchoring notes or timers to an object. Information and compare can be thought of as traditional visual question answering tasks, while share and anchor are more of a traditional widget tasks. So how do these parts come together to actually enable XR objects? So first, objects in the camera stream are classified on device using MediaPipe, producing labeled bounding boxes for each object. Using AR Core, the device localizes itself in 3D space and acquires a real-time depth map of the scene. To localize detected objects, we cast a ray from the center of the bounding box from the device's screen towards a depth map, and the hit point then becomes the 3D coordinate of that object in space. We then instantiate a multimodal large language model dedicated to this object using Pali, and provide it with a custom prompt and object image to obtain the relevant metadata, including things like its name, cost, and any other relevant details that are provided. In our open source implementation, though, this has since been updated to use the Gemini API. The context menu is then populated and anchored to the object, allowing the user to take their desired actions. So as I mentioned, we couple an LLM to each identified object, essentially running one conversation instance per object, shown here. And we also have a dedicated object comparer, which compiles this information from all these multiple objects and allows user to ask more comparison type questions. And this system also can visually identify objects as part of its response when appropriate. So moving on to our evaluation, we conducted a user study with 8 participants comparing the interaction flow of using XR objects to a state-of-the-art multimodal LLM assistant interface, in this case the Gemini app, for completing object-specific tasks in simulated grocery shopping and at-home environments. So each participant completed 6 tasks using both systems, which included retrieving and comparing information about different objects, sharing objects with others, as well as anchoring widgets and setting timers. So we recorded their task completion time and qualitative feedback in 2 surveys. On average, task completion time significantly reduced by about 31% when using XR objects compared to the baseline chat interface. And after using each system, users, as I mentioned, filled out a survey adapted from the Haley framework, where they rated their agreement with various statements on the ease of use, satisfaction, and overall effectiveness of their AI-driven human-computer interactions. You can find more details in the paper, but at a high level, while we didn't find significant differences in the data, we did some skewness analysis and revealed some insights, such as high ease of information retrieval for both conditions, as well as satisfaction ratings being more positively skewed for XR objects. And finally, to gain insights on the influence of device form factor, since we knew that we were not using what our ultimate vision is for XR objects, we also had users complete a survey in which they selected their preference between this baseline chat condition and XR objects when envisioning their use both on a smartphone, as they had, as well as a head-mounted display. And as we expected, we saw a significant preference for an XR objects-like interface when participants envisioned the interactions occurring on a head-mounted display. So we also envisioned several applications of XR objects and augmented object intelligence. So as we saw earlier, while cooking, XR objects could recognize ingredients, suggest recipes, or identify allergens, as well as allow users to have this sort of hands-free queries and anchoring of different timers and widgets that are useful for the whole multi-step cooking process. In stores, XR objects can assist users by providing details like prices, calorie info, product comparisons. It can also translate labels and provide visual indicators, and perhaps in the future offer personalized recommendations. In this case, a tourist is asking which of the detergent brands is better for washing black-colored laundry, and then the system provides a visual indicator of which object they should use. XR objects also invites interactive discovery of information about the objects that are around us in our lives, allowing for sort of direct Q&A to reveal things like interesting facts or instructions, how to take care of things, etc., for these specific objects. And in the future, we also see XR objects as being a valuable medium for interacting with IoT devices, allowing for this sort of on-demand direct controls and added visualizations that you wouldn't get with just your typical smart speaker or smart device. So finally, let's briefly discuss some of the limitations and future work. So first, we recognize that LLMs are an emerging technology which, of course, can hallucinate. While our work was focusing on exploring spatial interaction, not accuracy, one participant noted that the intermediate feedback steps provided by a system like XR objects, such as indicating which object was the focus of the LLM's response, made it easier to spot when a hallucination might have been occurring. Additionally, while object detection is happening entirely by the system right now, beyond repositioning the device, there's no direct way for users to signal which object they want to interact with. In the future, we think it'd be useful to add additional gestures or indications that to help guide the system towards the user's focus. And additionally, more context about the user and their environment will, of course, further enrich these interactions and potentially allow the action context menus to be customized accordingly. And finally, of course, we're most excited about the opportunity to bring this into real headsets. We're optimistic that HMD companies will provide API access some point in the near future. And in parallel, we're currently exploring other solutions such as device-mounted egocentric cameras. And we were also really excited to see such familiar interactions showcased in Meta's recent Orion glasses demo. And we hope that our work can help inform how we might best design these object-centered XR interactions in the future. And so thanks to all for your attention. If you're interested, please try our open source version, and I'm happy to answer any questions.
Steve Feiner, Columbia University. Great stuff. One question I had looking at the pictures in the paper and in the talk, the menu that you created looks pretty much the same for every object. You recognize where it is, you put up a collection of things to do. And they may vary from one to another, but the actual layout doesn't seem to vary. It doesn't seem to know about blocking something like your timer blocks my view of the thing I'm trying to time. Right. Have you thought about ways of being able to go and take into account something about the shape of the object, important parts versus less important parts, to lay out the information in a way that makes more sense per object?
Yeah, thank you. That's a great question. So yeah, we've definitely thought about that as the ideal version of how these sort of menus and interactions may take place. In this case, we were sort of exploring an initial step of what might be the most broadly useful actions that might take. But we're definitely are aware that in certain situations, there may be different categories that are more relevant. For example, if you're doing something like cooking versus studying or something like that. And at the same time, to the other part of your question, things like the object geometry and occlusion is something that our system, which is just currently running on a smartphone, is not taken into account, but it's something that is on our mind, and we would definitely want to address and incorporate that in the future work. I think that would be really powerful.
Okay, thank you. And ways you can manipulate the objects as well. Maybe the manipulation could
exactly,
be
yes.
Thank
definitely.
you.
Thank you, Steve.
Thank you for your really amazing work. I'm Sean from NYU. So I'd really like how this system can interact with the real world without the pre-registration. So I was curious, can this system can handle dynamic changes in an object state, like the attributes? So if like something turned on or off, can it recognize that different states or attribute of that object?
Yeah, that's a really great question. The answer is right now, no. We are effectively, when we run that pipeline that I showed before, where you have an object that's detected, media pipe identifies it, and then you sort of do this casting into the world. Right now, that just runs effectively once, and we don't update that again. but I can imagine a higher level layer in there where that is kind of looking out for changes and rerunning that classification. That could potentially give you some sort of like statefulness and determine like, or some kind of crude object tracking, for example. Right now, in this sort of initial implementation, you would place an object and it is not necessarily tracked, so it doesn't handle dynamic changes to the scene, other than moving around the camera. If you move around the camera, it will appear the spatially synced, but we're in our current version. We're not handling these changes. But if it's something you're interested in implementing, it's open source, so you can feel free to make some contributions too.
Got it. That would be amazing, because after integrating with the attributes, I think there can be the action menu and also like the attribute menu and all things integrate together. That would be amazing.
For sure. Great point. Thank you. Thanks for the
Thanks so
question.
much.